Hello, I'm Ali Akbar.
And I'm Hasan Sadiq.
We are from Indonesia. Here, we want to present our research. The title is Innovation of Polyethylene Plastic Waste Synthesis to Activated Oil Fuel Using Carbon Catalyst with Activated Cassava Skin by Zinc Chloride as an effort to realize SDGs 2045.
Plastic is a material made of polymer that functions as a packaging material. The use of plastic in the world is increasing along with the development of technology, industry, and also the population. The increasing use of plastic has resulted in an increase in the amount of plastic waste. According to the Ministry of Environment and Forestry, the total national waste reaches 67.8 million tons every year, with the waste of the plastic reaching 15% of the total national waste and increasing by 14% every year. This makes plastic waste the second largest waste after organic waste and needs to be handled.
In the distribution diagram of waste management, it shows that more than 60% of the waste is only buried in landfill and a few of them is burned, recycled, buried, and unmanaged. This shows that waste management in Indonesia has not been maximized, so that if it is allowed to continue, it will certainly cause more negative impacts, namely pollution that is getting worse.
On the other hand, we know that Indonesia have range of plants. One of the plants is cassava, which processed into various foods. However, the skin of cassava is often neglected and doesn't get enough attention from the public, causing its utilization to be less than optimal. In fact, the content of cassava skin is very useful, which shows at the slide. Cassava skin also has 44 until 50% of carbohydrate, which has the potential to be used as carbon, which can act as an absorbent and catalyst.
So, we make a solution which is converting polyethylene waste into fuel through a pyrolysis process that helped by cassava skin activated carbon catalyst. Then, the problem formulation of our research is, first, what are the characteristics of cassava skin activated carbon as a catalyst? Second, how to manufacture polyethylene waste fuel as an alternative fuel. Third, skin activated carbon as a catalyst in the process of making polyethylene waste fuel.
Then the objectives of our research is the first one, we analyze and determine the characteristic of cassava skin activated carbon as catalyst. Then we knowing the procedure for making polyethylene waste fuel. Lastly, we analyze and determine the effectiveness of using activated carbon as catalyst in the process of making fuel from polyethylene waste.
The process of our research begins with preparing the tools and materials to be used. The steps are: first, dehydration of cassava skin process. Second, cassava skin carbonization process. Third, shifting carbon with 100 mass shift. Fourth, carbon activation process with zinc chloride. Fifth, activated carbon test and implementations. Sixth, putting HDPE and LDPE waste materials into the pyrolysis system. 7. Catalytic cracking process. 8. Polyethylene waste fuel is formed. 9. Polyethylene waste fuel test.
First, the water content in activated carbon obtained is 6.11%. The percentage is in accordance with the national standard Indonesia limit, which is a maximum of 15% and includes low levels. This low water content is true because the surface of the activated carbon contains fewer polar functional groups, so that the interaction between polar water vapor is also minimum.
Furthermore, the result of ash content test of cassava skin activated carbon of 5.83%, where this value meets the standard national Indonesia criteria, which is maximum of 10. The purpose of the determination or test of ash content is to determine the metal oxide content in activated charcoal. The value of ash content shows the amount of residue from the end of combustion process in the form of mineral substances that are not lost during the combustion process.
Then, the test result for volatile substances are 9.88%, which value is in accordance with the national Indonesia standard criteria, which is a maximum of 25%. Carbon with high volatile substance will produce high combustion smoke when the carbon is used, so that a low percentage of volatile substance is recommended because the combustion smoke that is formed also low.
Finally, the carbon content in cassava skin activated carbon is 84.29%. This value has met the Indonesian national standard, which is at least 65%. Based on all characteristic test results, activated carbon meet the Indonesian national standard criteria.
And this is the result of FTIR test. In terms of the spectrum graph, the spectrum that shows the absorption of the OH group has a broad and sharp downward spectra in the 3 carbon samples. This indicates that the hydroxyl group is recorded strongly on FTIR or has a high intensity. However, the OH functional group that experienced a shift in wave number was smaller and sharper after activation, while the wide absorption band was true to be due to the presence of a lot of water.
In the absorption band of cassava skin activated carbon before and after 10% zinc chloride activation, it showed the absorption of CO groups at wave number 1539 until 1697 cm, and other functional groups such as CH2 and aliphatic CH.
The result of the synthesis of polyethylene waste fuel with catalyst is 22 ml and the color is white yellow, while the synthesis without the catalyst produced fuel of 5 ml and the color is brown.
Then we compared with diesel. It showed that polyethylene waste fuel has a destiny of 0.34 gram per milli, while diesel fuel is 0.78 gram per milliliter. Based on the result of destiny test, diesel fuel has a higher destiny than polyethylene waste fuel.
In addition, polyethylene waste fuel produces a faster burning speed than diesel fuel, which is 1.32 minutes, while diesel fuel is 1.47 minutes.
The volume of water evaporates in the water heating process using polyethylene waste fuel is 8 ml, while diesel fuel is 5 ml.
Okay, the conclusion from our research is polyethylene plastic waste has been successfully synthesized into alternative fuels through a catalytical cracking process with the help of an activated carbon catalyst from cassava skin waste. The result of the characteristic test and FTIR activated carbon activated with 10% zinc chloride showed that activated carbon from cassava skin waste was successfully produced with good quality according to national standard Indonesia.
In addition, cassava skin activated carbon catalyst activated with 10% zinc chloride was very effective in reducing the temperature and reaction time in the cracking process. This effectiveness can be seen in the polyethylene waste fuel produced, which is 22 ml. This figure is higher than the conversion process without a catalyst, which is 5 ml.
Further research is needed for carbon-activated substance so that more comparisons can be obtained and can be used as research reference materials.
This is the documentation of our research. And this is the reference. That's all I can say. Thank you for your attention. If there are any mistake, please forgive us.
And don't forget to support us in the 2022 Genius Olympiad.